Okay, for number 3 to 6, it's given a certain piece. And notice it says non-calc. If you see log base A of 5, we're going to put in 0.235. And then for log base A of 2, we're going to replace it with 1.392. And then log base A of 3, we're putting in 0.049. So here's our goal. We want to use some combination between 5, 2, and 3 to create the given log. So in this case, y'all remember when logs were divided, how we separated them?
Uh-huh.
How did we? What operation?
Subtraction.
Subtraction. So this would be log base A of 2 minus log base A of 3, you know. It's like when you think too fast, you end up writing the wrong thing. Oh well. So we have A of 3. And we have those components, right? So all of this will be replaced with 1.392. And all of that will be replaced with 0.049.
You said that as a question.
Uh-huh. How many would that be then? 1.3, how many? It's basically 92 minus 49.
I can't count with 3.
4, 3? I agree. 3, 4, 3, and done. So when you're doing these type of problems, just kind of ask yourself, what operation can I use following these 3 or using these 3 numbers? Or sometimes it could be repeated. So let's go on to number 8. Okay, Hunter, let's read the instructions.
For numbers 7 through 16, true or false? If false, show to make it true.
Okay, so looking at number 8, I want to look at it from this side. Whichever side you look at, it really doesn't matter because from here I can actually separate this. What is happening? If I have log base A of m over n, then we basically apply that on number 4.
Mm-hmm.
When it's divided, we separate it by what operation?
Subtraction.
Subtraction. So really in the end, when I expand this, it should look like this. And that does not look like the initial. So this one has to be false. For number 10, what do we think? True or false? I would start right here. Can we start by putting the x on the outside?
Mm-hmm.
In the front, I mean?
Mm-hmm.
So we have x log base n of m times n. And then what do we do after that? Separated by what operation?
Addition.
Addition. Now, when we are doing the addition, let's kind of think about what's going to happen. Should I take that x along with me when I do separate it? Wasn't it all over a while ago? So let's go ahead and put it together. So we have log base, or x times log base n of m. And then we have plus x times log base n of n. Let's see if y'all know this special rule. When you have a log with a little number and big number that is identical, what happened to it? It becomes cancel, meaning replace with 1, right?
Uh-huh.
So if that goes away, isn't this what I see basically?
Uh-huh.
So that is true.
Uh-huh.
That's why when we did natural logs, as a reminder, what was natural log of e?
Yes.
Natural log of e. Wasn't that 1? Because we have understood little e. So we have the little one and the big one's identical with the log. It cancels out, meaning we have the understood 1. Same rule on this one. Okay, let's go on to the next page. These should be pretty much a reminder, right? Hopefully. If not, you're going to have to focus quite a bit. Okay, on number 2, I want to circle the inside number. I want to manipulate this and then figure out what can I do with these 2 numbers to make it look identical. So the first thing I'm going to do, ask myself what is common between 8 and 4. Could I write something in terms of 8 and 4 by the same base number of what?
2.
2. Since 8's on the bottom, I'm going to think ahead and say 2 to the power of negative 3. So how am I going to rewrite 1/4 then?
2 to the power of negative 2.
2 2 to the power of negative 2. And then wrap it up and leave the power as it is because I'm not messing with that at the moment. And then what I can do is, as long as my base numbers are the same, they go away, I can now set the exponents to each other. Now keep in mind for the exponents, we're going to distribute the negative 3 and distribute the negative 2. So we get negative 3x plus a 3 is equal to negative 2 plus 2x. Is everyone good with where I'm getting this?
Multiple distribution of x.
Because x minus 1 is multiple components. 1 minus x, also multiple. We're distributing those values. And then from here, we're looking at basically algebra 1, right? So I think I want to move the negative 3 over and make it a 5x. And move that over, we get a 5. So x must be how many? Must be 1.
Oh, yeah.
Could I plug this 1 into my power here and see if it is identical? It will be. Hopefully you'll trust my answer on that. All right, let's move on to number 10. The bases are quite tiny, right? So let's see how we should go about this problem first of all. Y'all remember drop and cross from, when was it, algebra 2? Maybe?
Only the phrase.
Okay. If you don't remember, here I go. The drop is the 8 goes on the small number, 27 goes over, and the remaining power goes on the other side.
Oh, yeah.
Is that little 8? Yeah.
Yep, both times.
And then we can kind of take something out on the next one. Because it's been added, what operation do I use to condense?
Multiplication.
Let me actually do one more step. Let's bring this as our power. I don't know what's happening in that class.
That was an ad.
Was it an ad?
That, some sort of.
And then we're going to go ahead and put these together by multiplying. We have log base 8. Jack, I'm recording.
Yeah.
And then let's go ahead and put the other side that I did not mess with. Now that we have a single log, I could let the argument be equivalent to each other. So we have 27 is equal to x cubed. So something times that exact something is 27. What does that give us? X equals 3. Has it been a while since y'all played with the logs or worked with the logs? Okay.
Why is
Mm-hmm.
x squared minus x cubed?
It's supposed to be a multiplication dot, but it looks like a subtraction. Yeah.
Oh, does it look like a minus sign? It should be
Yeah,
multiplication.
Yeah. Thank you.
When logs are condensed from plus sign, we multiply.
Yeah.
Thank you. Okay, let's go on to number 11. Can we drop and cross on number 11 too?
No.
We're going to drop the 4, cross the x to the other side, and 256. Now, if I take 4 to the power of something, it gives us 256. What do you think that x should be?
Yeah,
4.
4, 16, 64, 256.
Yep. 4, 16, 64, and 256. And it's okay if you have to show the work on the side, but by heart I have that memorized.
Thank goodness for
All right, let's go on to the back. Ooh, 3 on the back.
power 4. Power 4.
Okay, let's drop and cross on the next one, but I want to rewrite this. This guy right here.
Yeah.
That's really 9 to the power of 1/3.
Yeah.
So when I drop and cross, I'm going to drop the x over right here. 1/6 becomes our new power. Then I have 9 to the 1/3. Okay, is my x by itself at the moment?
No.
So I need to take this whole thing and multiply by the what? Reciprocal. 6 over 1. Because when I multiply by the reciprocal, it's going to reduce everything to 1. So we have just x. Write the power of 1 if that makes you happy. And we know all this is going to be what? 2? So
What?
9 squared is how many?
Oh, yeah.
81. Boom.
Magic.
Yeah, magic. That's right. Okay, are we good to go on to number 20? Yay? Okay. Let's also rewrite this right here as 2 to the power of 1/2. You could change it after, but I think it's convenient to change it now. So I'm going to drop that one, 2 to the 1/2. And then cross the 8 as my new power. Then here's my x. The only part is going to be reducing this guy right here. What is half of 8?
4.
So we have x equals 2 to the power of 4. And by memory, that should be 16. All right, last one. Let's drop and cross. So drop this guy right here. Cross the 1/4 over to the other side of the equation. How am I going to write the radical 3?
You wrote 1/2.
Oh yeah, that's a 3/4.
Thank you.
I wasn't done. You see that? I just had to complete it. 3 to the what? 1/2. This question looks pretty similar to this one right here. So we're going to multiply the whole thing by the what?
Reciprocal.
Reciprocal power. So on the left, it's going to reduce to 1. And all this will give us 3 squared. How many is 3 squared? 9. Done.